Hello, everyone. Once again, this is Stuart Mitchell. I'm a graduate math student at Wayne State University. I work for Professor Oaks, and I'll be continuing on with Lecture 2 for the behavior of variables of numbers and variables. Okay, so we have four problems we're going to be going over today. They each fall into two different categories, or not each fall into two different categories. The first two fall into one category. The second two fall into a different one. So the first two, I'm sorry, that was not the right one. 1 and 2 fall under the distributive property of multiplication, and I will show you how to carry that out. The second two, 3 and 4, fall under a different property. They follow under what could be called the special properties of 0 when dealing with division, because 0 is can be a tricky number when you're dealing with things at times. Okay, so let's revisit the first two. Okay, so for these first two problems here, just in general, when you're dealing with the distributive property, how you carry that out, say you just have any arbitrary numbers like A times the quantity B plus C. So you take this A inside to the B and to the C and multiply it to both of them. And then you'd end up with AB plus AC. And it's important to note that when you're dealing with the distributive property, it deals with one number outside of a quantity that's being multiplied to a quantity that has addition or subtraction. Because it'd be a different rule if you are talking about multiplication on the inside, it would be a different format. Say you had like A times the quantity B times C. That would fall under the associative property of multiplication, and you could interchange any of these, and you just multiply all three together, and you'd end up with AB and A times B times C. Okay, so moving forward to these examples, it's important to note too, this works the exact same way. If you had a subtraction symbol here, you just change it down there to, or change it in the middle too. So it wouldn't change too much. So if we are talking about the first one that we're doing, the 4 times the quantity 3 plus 6, you would multiply this 4 to the 3 and to the 6, so that you'd end up with 4 times 3 plus 4 times 6, which would then give you 12 plus 24, which then would equal 36. So that is how you do that one. I will revisit this one after we do the second one, because there is a second way you could think about it, if that makes it easier for you. And I will show you what that looks like in just a moment. But same idea down here, it's just with variables instead of numbers. It works the exact same way, because all a variable really is just an arbitrary number that you're using as kind of just like a placeholder for it. So you can think of these as numbers. It's just you don't know what they are. That's why they're called a variable, because they could change depending on like what they actually are, or they could change based on what you choose. So for this one, it works the same way. You multiply the 5 to the x, and then the 5 to the y, and you move this subtraction symbol down in between them. So you'd end up with 5 times x minus 5 times y. And that'd be your final answer for that one. Now, before we get to the next two, a second way to potentially think about this problem, it could be cast in a slightly different light, is if you considered it an order of operations problem. Since you're just since you're dealing with these concrete numbers that you're seeing here, and you don't have variables. So say we had this 4 times 3 plus 6. Well, the order of operations is parentheses, exponents, multiplication, division, addition, and then subtraction. Parentheses and exponents are in a league of their own. They have to be done separately. They can be combined. But multiplication and division, as well as addition and subtraction, like if you're dealing with multiplication and division in the same problem, you can just go left to right with it. As well as with addition and subtraction, they're in the same league, so you can deal with them left to right. You don't have to do one before the other, even though they come first, per se, like in this acronym. The only ones you have to account for separately are parentheses and exponents. But multiplication and division go together, and so do addition and subtraction. So you can deal with those in order. If there's multiple instances of multiplication and division and addition and subtraction in a given problem. For this case, we just have one instance of addition and one instance of multiplication. We also have parentheses, and parentheses come first. They always come first. So we have to deal with what's in parentheses before we do anything else. So that would mean that this would be equal to 4 times, and then we have to simplify 3 plus 6. Oops, sorry, that was terrible. This stylus is really not having it with me today. Okay, sorry about that slight hiccup. We'd have 4 times 3 plus 6, which is 9, which we can drop the parentheses now since it's just one number, which is 4 times 9, which again gives us 36. So you'd get the same answer either way. Either way works. You can do it however you prefer. That's just, this is probably the way I would choose to do it with like numbers and not variables, because it's a little bit quicker. It doesn't involve as much calculation. But either way you prefer works. But for variables, you have to apply the distributive property because you don't know what this quantity is. You can't simplify what's in parentheses first. You just have to carry out the multiplication how it is. Okay, and then for 3 and 4, we're dealing with a different property. We're dealing with the special property of 0. Okay, so for both of these, they're a little different. I know you see a 0 in both of them. The key difference is that the 0 is in the denominator in number 3 and in the numerator in number 4. It's important to note that whenever, like for any number at all, so just say you have any number x and you divide it by 0. This will always be undefined. Always. And the reason for that, it's a little bit complicated to like say it completely technically and accurately. However, if you think about it in a logical way, when you're dividing a number, you're saying you're dividing it into however many pieces. Say like this denominator was 9 and you had 7 nines. So you're dividing 7 into 9 different pieces, which you can do. You can split it up. And when you're dividing a number by 0, what you're saying is you're dividing it into 0 pieces, which is impossible because you can't take something that is you can't take something that has value and then make it and divide it 0 times. Like you can't divide it up into 0 pieces. You'd have to in order for that to happen, you'd have to divide it up infinite times, so it'd end up being nothing. So that's impossible to carry out. So we just say it's undefined. You can't define that division. So if you ever see something divided by 0, I should I can actually do this since I have colors on my side. We're going to call that a red flag. Whenever you see that, mark that as a red flag. You can't have this happen, and it would always be undefined. Okay, so we saw what happened there. This is clearly going to be undefined. That's one separate instance of a special property of zero when you're dealing with division. Another one, which is actually allowed, and it's actually it behaves a lot nicer than that one does. When you have zero in the numerator, you can, and you're dividing it by any non-zero number. That's important to note, because if you have 0 divided by 0, you're going to get a big undefined case too. So that doesn't work. But it's important to note that 0 divided by any number be whether it's positive or negative, as long as it's non-zero, it's going to equal 0. So we'll have 0 divided by 12 is equal to 0, which this is a nice property too. This isn't a red flag. This is a nice like green flag, go, like yay, go you. It'll be nice and easy division, because you have anytime you see 0 in the numerator as the only number in the numerator, divided by any number, whether it be positive or negative, as long as the denominator is not 0, if you have 0 in the numerator, you'll end up with 0, because essentially what you're saying in this case is you're taking nothing and you're dividing it by a number. You're dividing it into a certain number of pieces. Well, you can't, no matter how many times you divide nothing, you're still going to end up with nothing. Like that's the logic behind it. So you'd still end up with 0 no matter what number it is. Just keep in mind, this 0 divided by any number except for 0. You can't divide 0 by 0. That's a big undefined case as well. So just keep that in mind too. But that essentially covers this area. Thank you for listening, and I will you'll hear me next time for the lecture. You won't see me. I don't know why I said that. Sorry about that.